very, very interesting emergent behavior because of the interactions of different building blocks. We have stocks and flows, and associated with them, we're going to see causal loop diagrams. Causal loops are going to be associated with those stocks and flows. Stock and flow diagrams will be incomparably more precise than causal loop diagrams, but we'll be able to talk about the feedback loops, identify the feedback loops associated with stock and flows as well. But the actual model we're building up step by step by step with pieces that are small in number. We basically have stocks and we have flows, and then we have some additional components called auxiliary variables and constants. And if you want to throw in a couple more that are sometimes used, table functions to define graphically functions, etc. So we have a small modeling vocabulary here. The key ones are stocks and flows. The others are kind of ways of simplifying the depiction or ways of simplifying the presentation of it, but the essential math has to do with the stocks and flows. Okay, that's the real sort of essence of what's going on mathematically, all in the stocks and flows. So here we have a small modeling vocabulary, and the power lies in combining just a few elements. So the analysis here is conducted predominantly in terms of stocks and flows. So we look at the behavior of stocks over time, or flows over time. And it directly maps on a one-to-one basis, well, not quite one-to-one, but in a straightforward way, onto ordinary differential equation. We'll see that those underline this. And that allows us to analyze it with a whole other set of tools, which are not commonly used by modelers, by most modelers, but are by some. We're going to contrast that, so we're going to be spending our next couple weeks with stock and flows. Now this is in contrast to agent-based models, which we'll be coming to later in the term, where we have a much larger modeling vocabulary. We have state charts, we have events, dynamic and static events, we have composition of sort of a global environment and individual agents who can be situated in space or in networks of connections to one another. And we're going to have a large set of primitives to draw on there, a large set of these elements out of which we build up the model. And the power here is a flexibility combination of the elements. The mathematical underpinnings are less direct, and we can't just directly map it to a single sort of a crisp mathematical notation that allows for analysis. So for now, we're spending time on stocks and flows and system dynamics modeling. Okay, so